Hi everyone, my name is Luisa and I am a researcher at the Biomedical Imaging Group in Rotterdam at the Erasmus Medical Center. I am going to present a paper titled Deep Learning-Based Retinal Vessel Segmentation with Cross-Modal Evaluation. This here is an example of two retinal imaging modalities, Fundus Photography and Scanning Laser Ophthalmoscopy. Essentially, these images depict the interior part of our eyes, where most of our vision happens. Among other structures, they show our blood vessels, and the retinal vessels are among the first structures affected in a number of pathologies, such as diabetes and hypertension. Thus, an accurate segmentation is the first step to compute quantitative, repeatable, and automatic biomarkers. If we analyze the works published on retinal vessel segmentation, we can see how most of them use fundus images, while SLO has not been that studied yet. However, this is slowly changing, as SLO is becoming increasingly common in clinical practice, and it can provide higher quality information in some patients. Moreover, the proposed approaches for fundus are very varied, using different techniques and, in the specific context of convolutional neural networks, a wide variety of architectures and parameters, all obtaining similar results. Therefore, the first task of this work was to implement a baseline network derived from the literature with a comparable performance to the previous networks. After that basic pipeline was defined, the second and main goal of that work was to study if a model trained in one modality could be used to segment vessels in the other with sufficient accuracy. To that end, 6 public databases with manual annotations were used, 2 SLO and 4 Fundus Photography. A unit was used as base model, and we studied how the number of patches per image and their size affected the result. Then, the model was trained using all the available datasets from one modality and testing using all the datasets from the other modality. To evaluate, accuracy, sensitivity, and specificity were used, as these are the measures used by previous authors in literature to report their results. However, DICE score was also included to have a broader idea of the performance. Here we can see some results of training and testing the model in individual datasets in comparison with the ground truth data. And we can observe that, though not perfect, the results are quite comparable visually. For the quantitative results, we are using as reference the inter-rater accuracy, sensitivity, specificity, and DICE computed from the datasets that had several manual annotations per image. These references are shown in the diagram with dashed line. If we observe the metrics as a function of the patch size in individual datasets, it is clearer that larger patch size work better in our model. Also, sensitivity and DICE are the parameters that benefit the most. If we observe the metrics as a function of the number of patches acquired per image in the individual datasets, we can see that, while a minimum number of patches is required, there is a point where little improvement can be seen. Again, sensitivity and DICE are the parameters that benefit the most from a sufficient number of patches. Finally, regarding the quantitative results for the cross-modal evaluation, we can observe how models trained and tested on the same modality perform similarly to individual datasets. Moreover, the model trained on Fundus and tested on SLO has also a good performance. But the same cannot be said for the opposite case. The model trained on SLO and tested on Fundus Photography has especially poor sensitivity. To summarize, a general-purpose state-of-art CNN is able to obtain results comparable to previous approaches from the literature. The sensitivity, accuracy, and specificity of the model is around 90% for all the individual datasets in the best number of patches and patch size configuration. Finally, a model trained on Fundus Photography is able to segment scanning laser ophthalmoscopy accurately, with values around 90% for sensitivity, specificity, and accuracy. The same cannot be said for the model trained in SLO and tested on Fundus Photography, which shows a drop in sensitivity below 50%. That was all from the presentation. Thank you for your attention, and please do not hesitate to check the full paper and to contact me to discuss any questions that you may have.